You know that specific sinking feeling you get right in the pit of your stomach?
Oh, I know exactly the one.
You're in a multi-story parking garage. You are already 10 minutes late for a meeting, or maybe a movie.
Yeah, the pressure is on.
You're just endlessly circling level 3. And every single time you see a gap in the cars, you get that little surge of hope.
Right, only to realize it's a tiny Fiat pulled all the way forward.
Fighting in the shadows. It's devastating.
The phantom spot. It is the ultimate betrayal.
It really is. And then, you have a guy in a massive SUV right behind you.
Inching closer and closer.
Exactly, just adding to the pressure. And it feels like a personal failure, right?
Yeah.
Like you just have bad luck or you picked the wrong lane.
But it's not.
Right. Looking at the deep dive we're doing today, that frustration isn't about luck at all. It's actually a data failure.
It's a massive data failure. And what's really interesting is that we tend to think of this as just a nuisance, like, oh, parking is annoying.
A minor inconvenience.
Exactly. But when you look at the research we have for today, specifically this source on the Favoriot Insight Framework, you realize that annoying is actually a silent crisis for cities.
A really expensive one.
Right. We are talking about millions of dollars in wasted fuel, massive carbon emissions from all those idling cars, and a huge hit to economic productivity, just because people can't figure out where to put their vehicles.
Which is exactly what we're unpacking in today's deep dive. We're looking at this Favoriot framework, which claims to completely transform smart parking.
And it does so in a really unique way.
Yeah, I have to be honest. When I first saw the topic, smart parking, I thought, okay, we're just going to talk about sensors today.
Well, it's a hardware talk.
Right, but this source material goes way deeper. It argues that parking isn't actually about managing cars at all.
No, it's about managing trust.
Trust. That is the core thesis here, and it's a pretty powerful one when you stop and think about it.
It really is. I mean, think about it from a citizen's perspective, right? The parking garage or the curbside spot, that's often your very first interaction with a city or a business.
The first touch point.
Exactly. And if that interaction is chaotic, stressful, and inefficient, you immediately lose faith in the administration running it. As the source says, when a city loses time, it loses trust.
That is a heavy statement for a parking lot.
It is.
But it makes total sense.
Right.
If you can't even manage the white lines on the pavement, why should I trust you with zoning laws or healthcare?
Precisely. So this framework, the Favoriot Insight Framework, it's designed to move facility managers from that initial chaos into what they call prescriptive action.
Which sounds very clinical.
It is a bit, yeah. It's basically a journey from I have absolutely no idea what is happening in my parking lot to I am solving problems before they even happen.
And they break this journey down into 6 distinct layers. Layer 0 all the way to layer 5.
Which is a great way to structure it.
I want to walk you through these because they really build on each other in a logical way. And we should start exactly where the source starts, with layer 0.
The most important one.
And the part that surprised me the most. Because this is supposedly a tech framework.
Right.
But the very first step involves absolute zero technology.
Layer 0 is intent and context. And you're right, this is the step that gets skipped, honestly, 90% of the time.
Why is that? Is it just the excitement of buying new gadgets?
Oh, totally. It's the shiny object syndrome. A city mayor or a mall owner decides, we need to be a smart city.
We need AI.
Exactly. So they go out and buy 1,000 sensors and 50 cameras. They pay to install them, turn them all on, look at a dashboard full of blinking numbers, and then realize they have absolutely no idea what problem they're actually trying to solve.
So layer 0 is essentially the pause button.
It is. It asks the fundamental question, why are we doing this in the first place?
And the source lists a few potential whys, and they're actually quite different. You have things like reducing congestion, which is the obvious one, but then you have ESG reporting.
Environmental, social, and governance goals.
Right. Or, on the flip side, preventing revenue leakage, making sure people are actually paying.
And those goals can entirely conflict with each other if you aren't careful.
How so?
Well, if your intent is purely revenue generation, you might want to maximize occupancy at all times and have really strict, aggressive enforcement on expired tickets.
Pack them in and fine them if they stay too long.
Exactly. But if your intent is ESG, say your main corporate goal is to reduce your carbon footprint, then your main metric isn't revenue, it's reducing search time. The amount of time people spend circling with their engines running.
Right, because less circling means less emissions.
Right. You just can't optimize a system if you don't know which variable matters most to your organization.
One thing I loved in this section was the discussion on defining what normal is.
Oh, that's crucial.
It sounds so simple, right?
Yeah.
But it's actually really tricky in practice.
It is. I mean, if I tell you that a parking lot has a turnover rate of 3 cars per bay per day, is that a good thing or a bad thing?
Well, I would assume it entirely depends on the lot.
Precisely. If it's a commuter lot for a suburban train station, 3 is probably really high. You expect people to park once at 8 a.m. and stay there all day.
Right.
But if it's a busy shopping mall on a Saturday afternoon, 3 is a total disaster. You want that turnover to be 5, 6, or 7 so more shoppers can actually get in the door.
So layer 0 demands that you establish these baselines first.
What is acceptable occupancy? What is an acceptable search time? Is it 5 minutes? Is it 20?
Because if you don't define normal in layer 0, you can never identify what is abnormal later on.
Exactly. You are just drowning in data without any context. You also have to agree on your risks here, too.
Like what you're actually afraid of happening.
Yeah. Is the biggest risk unauthorized parking in the disabled spots? Or is it safety in the dark corners of level 4? Layer 0 sets the rules of the game before you even start playing.
Okay, so let's assume we've been disciplined. We did our homework. We defined our normal. We know our intent.
We did the hard work.
Right. Now we can actually go shopping for the tech. This brings us to layer 1, the data foundation. This is the hardware layer.
This is the plumbing of the entire operation, and the source is very specific here. We aren't just talking about a bored security guard watching a grainy CCTV monitor.
Right, the days of the VHS tapes are over.
Long over. We are talking about advanced video analytics and true IoT integration.
Now that term IoT, the Internet of Things, it gets thrown around a lot in tech circles. But in this context, we're talking about connecting everything specifically to the Favoriot platform. Why is that specific connection so important? Why can't I just have a smart camera that records to a hard drive in the basement?
Because of fragmentation. Fragmentation is the enemy of any smart city project.
How do you mean?
Typically, a legacy parking garage is a Frankenstein monster of different vendors. You have a barrier gate from company A, a payment kiosk from company B, and security cameras from company C.
And none of them speak the same language.
Exactly. They don't talk to each other at all. The Favoriot platform acts as the middleware. It's the central nervous system that translates and connects all these fragmented devices into one coherent system.
That makes sense. The source also highlighted something called edge processing in this layer.
Yes, very important.
For you listening who might not be a network engineer, how do we break down why edge processing actually matters?
Well, imagine if every time you saw a car on the street, you had to call a friend in another country to ask them, hey, is that a car?
That would be incredibly slow.
And very expensive. But that is exactly what happens if you stream raw, heavy video files up to a cloud server for analysis.
Right.
Edge processing means the camera itself is smart. It has a chip right there inside the device that says, oh, that is a Toyota license plate ABC123, and then it just sends that tiny string of text data to the cloud instead of the whole video.
It's much faster and uses way less data.
A fraction of the bandwidth and much lower latency. And in a parking situation, speed really matters. You simply can't have a car waiting 5 seconds at a gate for a server in another state to decide if it can enter. It has to be instant.
The other piece of layer 1 that stuck out to me was OTA, over-the-air updates.
Crucial for maintenance.
It's basically like when my phone updates while I'm asleep.
In exactly the same concept. You have to remember, these are ultimately security devices. If someone finds a vulnerability in the camera software, you need to be able to patch it immediately. Remotely.
You can't send a guy in a van with a ladder to manually update 3,000 cameras across the city.
You'd never finish. So layer 1 ensures the system is secure, it's maintainable, and most importantly, it actually works.
Okay, so we have the intent with layer 0, and we have the solid plumbing with layer 1.
Now the fun begins.
Right, now we flip the switch. Layer 2, descriptive insights. This is the what is happening phase.
This is your dashboard. If you're the operator sitting in the control room with your coffee, this is what you are staring at on the screens.
And it's not just a boring list of spreadsheet numbers. The source talks a lot about heat maps.
Heat maps are fantastic for instant situational awareness. You can look at a 3D digital map of your entire garage and instantly see, okay, the red zone near the elevator is completely packed, but the green zone in the back corner of level 2 is totally empty.
Which seems like an obvious thing to want to know, but without the data, you really are just guessing based on a hunch.
You completely stop guessing. That's the key. But layer 2 isn't just for the guy in the control room. It is crucially for the driver, too.
Right. This is where those digital signboards come into play.
Exactly. The ones that say, level 3 full, level 4, 25 spaces.
I have to say, when those signs actually work and they're accurate, it is a thing of beauty. It completely changes your blood pressure as a driver.
It manages your expectations.
Yeah.
And it prevents that terrible shame reverse we talked about earlier.
Yeah,
You don't drive down the row hoping for a spot if the system explicitly tells you there is nothing down there.
it also handles the monitoring of these special reserve spaces, right? Like VIP, accessibility bays, EV charging.
Yeah, if someone parks in an EV charging spot but they don't actually plug in or they don't have the right credentials, the system sees that instantly.
So layer 2 gives us total visibility. We can see the car, we know where it is, and we can tell the driver exactly where to go.
But
the framework argues that this is still technically just reactive.
exactly.
We're just watching things happen in real time. To get really smart, we need to move to layer 3, diagnostic insights.
This is where the Favoriot framework puts on its detective hat. We finally move from what is happening to why is it happening.
It's the shift from simple observation to actual analysis.
Correct. The system starts proactively looking for correlations. Let's say your Layer 2 dashboard shows that every Tuesday at 4 p.m., the main exit lane backs up for 20 minutes. Layer 2 just shows you the traffic jam. Layer 3 looks at historical data and correlates it with outside factors. Maybe it's the weather, maybe a local sporting event, or maybe a shift change at a factory down the street.
So it might actually realize, hey, it rains every Tuesday afternoon lately, and when it rains, everyone skips walking and tries to drive out at the exact same time.
Exactly. Or it compares usage patterns, weekday versus weekend, event days versus normal days. It allows operators to spot hidden patterns that a human observer would absolutely miss because the data set is just too vast.
The source also mentioned it excels at anomaly detection.
Oh, this is huge.
The phrase dwell time came up here, which I found interesting because I usually think of dwell time for like tracking shoppers in a retail store.
Right, how long they stare at a display. But in parking, dwell time is critical for revenue and for enforcement. If you have a 30-minute quick loading zone in front of a terminal and the system sees a vehicle with a dwell time of 4 hours,
That's a massive anomaly.
that is an anomaly. Someone is abusing the spot. Or maybe it's a car in a handicap spot, but the license plate read by the edge camera doesn't match the state registry of disabled permits. Layer 3 flags these specific issues, so you aren't just looking at a sign that says full, you are understanding exactly why it is full.
Is it full because of paying customers?
Yeah.
Or is it full because all your retail staff are parking in the prime customer base?
That is a huge, huge distinction. If your staff are clogging up the prime spots, you are actively losing business every hour.
Because the customers give up and leave.
Right. Layer 3 gives you the diagnostic power to fix the root cause of the congestion, not just treat the symptom.
Okay, so we know what's happening and we know why it's happening. Now we get to the part of the framework that feels a bit like magic.
Layer 4.
Layer 4, predictive insights.
The crystal ball.
This is where we completely stop looking at the past and start looking into the future.
And this is exactly where the value of all that historical data stored in the Favoriot platform really shines. Once you have, say, a year's worth of solid data on how people park during the holidays or during major rainstorms or even just on payday weekends, the system can start forecasting.
So it can essentially tell a facility manager, brace yourself, next Friday is going to be absolute chaos.
Well, it's way more precise than that. It can predict occupancy by the hour and by the specific zone. It can say, based on current traffic trends and the upcoming holiday weekend, Zone A will reach 100% capacity by exactly 10:15 a.m.
That is a total game changer for operations.
It really is. It allows you to shift your entire mindset from reacting to traffic to preparing for traffic. If you know for a fact you are going to overflow in an hour, you can go ahead and open the auxiliary lot before the jam even starts.
You can schedule extra security staff.
You can adjust the air conditioning in the lobby because, a massive surge of bodies is about to walk through the doors.
It sounds like it completely removes the panic from the job. You aren't constantly fighting fires, you're just fireproofing the building.
That is a perfect way to put it. You are mitigating the risk before the risk even materializes.
Which sets us up perfectly for the final layer, the absolute pinnacle of the framework. Layer 5, prescriptive insights.
We've made it to the top.
We climb a mountain.
Yeah.
We have the data, we have the diagnosis, and we have the prediction. Now, what do we actually do?
Right. Layer 5 is all about action. This is the highest level of system intelligence. The system doesn't just predict a problem anymore, it actively recommends a solution. Or in some cases, it just automates the solution for you.
The source uses the term dynamic redirection here. I really love this concept. Can you walk us through what that actually looks like out in the real world?
Sure. Imagine the system predicts, using layer 4, that the main entrance garage will be totally full in about 20 minutes.
Okay.
Then layer 5 kicks in. It automatically communicates with the digital signage out on the main public road. Not just the signs inside the garage, but miles out on the approach.
Oh, wow.
And it changes the sign to say, main garage filling fast, please use the east entrance.
That is so smart. It solves the problem upstream.
Exactly.
The driver never even sees the traffic jam because they were diverted before the jam even formed.
It entirely smoothens the flow of the city. It can also suggest things like automated surge pricing.
Like ride-sharing apps do.
Exactly. If demand is absolutely skyrocketing for a special event, the system might recommend, hey, raise the hourly rate by 10% to encourage a faster turnover of spots.
Or going back to the enforcement side, if it sees that delivery truck in the quick loading zone for 4 hours, it doesn't just quietly log it in a spreadsheet.
No, it sends a real-time push alert directly to the enforcement officer's tablet. Unauthorized vehicle, Bay 42, issue citation.
Wow.
That is what we call closing the loop. But I do want to be very clear about something here because people often get a little nervous about AI making all these decisions.
Right, handing the keys to the machines.
The source heavily emphasizes human oversight in this layer.
So the robots aren't taking over completely just yet.
Not quite yet. The system provides the strong recommendation. It says, we highly recommend opening the overflow lot now. But a human manager usually still has to hit the approve button.
Ah, I see.
The massive difference is that manager's decision is now totally evidence-based, traceable, and auditable. You can look back 3 months later and see exactly why a decision was made based on exactly what data.
So we have gone from intent in layer 0 all the way up to prescriptive action in layer 5. It is a really comprehensive journey.
It's a complete paradigm shift.
But I want to zoom out for a minute. We started this deep dive talking about the personal frustration of the parking circle and the annoyance of being late. But for the people actually spending millions buying this infrastructure, the city planners, the mall operators, what is the real tangible payoff? Why go through the trouble of all 6 layers?
The source breaks it down into 4 main pillars of value, and they are really big ones. First is just pure urban efficiency.
Which basically means less time wasted circling and better overall traffic flow on the surrounding city streets.
Right. It unblocks the arteries. Second is environmental impact. This connects right back to those ESG goals we mentioned.
The sustainability aspect.
Yeah, you can't just put up a green leaf logo and say, we are a green city anymore. You need hard proof. With this Favoriot framework, you can actually generate a report that says, we reduced average vehicle search time by 4 minutes this quarter, which mathematically saved X gallons of fuel and prevented Y tons of CO2 from entering the atmosphere.
That is incredibly powerful data to have. It turns sustainability from a marketing buzzword into a hard, trackable metric.
Exactly. Third is economic value. This is the bottom line for the operators. Optimizing your current space means you might not actually need to build that incredibly expensive new concrete parking deck because you are finally utilizing the old one efficiently.
Saving millions right there.
And you completely stop revenue leakage, making sure every single car that parks is actually paying what they owe.
And the 4th pillar.
Governance. This is really about moving toward evidence-based urban planning. When a city council decides to widen a road or build a massive new transit hub, they aren't just guessing anymore or following a political hunch.
Right.
They have years of concrete Favoriot data showing exactly how their citizens move, where they stop, when they park, and why.
Which really just brings us all the way back to that core concept we started with at the top of the show, trust.
It does. Smart parking, when it is truly done right through all these layers, it becomes completely invisible.
Invisible.
Yeah. You drive in, you easily find a spot, you do your shopping, and you leave. There is zero stress. There is no confusion. When the public infrastructure works that smoothly, you just inherently trust the system, you trust the city.
And when the data is scattered and the tech is totally fragmented, that trust is just broken from the moment you pull in. It's just chaos.
It is. As the source material says perfectly, smart parking is not only about managing vehicles, it's about managing trust.
So the real call to action here isn't just, hey, go buy some more smart cameras. It's to actually contact Favoriot to move your facility from reactive management to this level of prescriptive control.
Exactly.
To stop relying on guys watching monitors manually.
Right.
And start using data to actually make proactive decisions.
Cities, malls, Big university campuses, major hospitals, they simply cannot afford to fly blind anymore. The density of our modern cities is just too high. The cost of failure is too high.
And the tech is clearly there.
The technology absolutely exists to solve this today.
It's a really compelling argument. It takes what is basically a mundane daily annoyance and turns it into a very solvable engineering problem.
It does.
But before we wrap up today, I had a thought that has been nagging me while we were discussing layers 4 and 5.
Oh, yeah. What's that?
Well, we've been talking all about how parking spaces are learning to actually predict our behavior, about digital signs that change to redirect us before we even know we need to be redirected.
Right, solving the problem upstream.
Exactly. If our parking spaces can be this incredibly smart, if a simple concrete box can anticipate our needs before we even arrive, what does that say about the rest of our city infrastructure?
Oh, that is the million-dollar question right there.
Because we buy smart sensors for everything now, right? Streetlights, trash cans, water mains, power grids. But are city planners actually asking the layer 0 questions for those deployments? Are they clearly defining the intent first? Or are they all just collecting massive amounts of data just for the sake of having data?
Honestly, I think if we rigorously applied this intent first, technology second framework to the rest of the entire urban grid, we would be living in a very different, much less stressful world.
Imagine a city where the traffic lights actually know you're coming, and the public trash cans automatically know when they're full and route the trucks themselves.
It's definitely the future.
It's a nice thought to leave on. Something for you to think about the next time you breezily pull into a perfectly available, well-lit parking spot. You might just have a very smart framework working behind the scenes to thank for it.
Let's hope so. Drive safe, everyone.
Thanks for listening. We will catch you on the next deep dive.